Okay, let me record. So a ball throws a vertical height of 0.6 meters before bouncing at point A on a ramp, as shown. Show that yes, sir.
Sir, I did this in class today.
Yes, so you know how to do it then. Is it not the same method? Try do the same method that I told you.
Okay, I'll try.
Okay,
sir.
Yeah.
I found the October paper.
Already? That was quick. Yeah, like I said, it's not hard to find. A ball falls through a vertical height of 0.6 meters before bouncing at point A on a ramp, as shown. Show that the velocity of the ball immediately before the bounce is about 3 meters per second. How can you show that? Who wants to help me out?
So you do your vertical SUVAT because you have vertical distance.
Okay.
I'd start by writing out SUVAT very quickly. Since the ball falls through the vertical height, can we assume it has 0 initial velocity?
Excellent. You can, okay. You can easily do a vertical SUVAT. Very well done. SUVAT. Acceleration is minus g. Initial velocity is 0. What else do we have? The displacement is 0.6. Good. You're trying to work out the final velocity.
So can we do v squared equals u squared plus 2as?
Yeah, because that's the final equation left. V squared is u squared plus 2as. Take out the u.
Sir?
Take out the u. Yes.
So why is it minus g? Isn't it going downwards?
Yeah, so it's minus 9.81. G is 9.81.
Yes, so why is it minus g? It's going downwards, right?
Do you mean why is it not minus 0.6?
No, sir, he means why is it not positive g?
Because
positive g.
it's accelerating down. You always take positive to be up.
So our teacher always told us positive is up and negative. I mean, the opposite. Positive is down and negative is up.
It doesn't really matter which way, as long as you indicate that which one you're using in the question.
It does matter in the multiple choice questions because the option of accelerating being up.
I've always used 9.81 going, like if it's downwards, it's positive and upwards negative, and I've always gotten it like right that way. So I'm confused.
Yeah, because you always assumed down is positive, meaning a down displacement is positive, a down velocity is positive, a down anything is positive. That's what you assume. The problem with this, if you stick to this, especially in the multiple choice questions, where it says which of the following gives the expression for the time or for the velocity, your answer is always going to be the wrong one. Because the exam always assumes up is positive and right is positive, because that's the convention. If you have a graph, this is the positive quadrant, positive x, positive y, negative y, negative x. So I know that's what you always did, but I'm just saying this is how I teach it. Because I need to make sure that you get all the marks or even the multiple choice questions. Does that make sense?
So every time I'm doing a SUVAT question, I have to consider 9.81 as negative if it's going downwards.
Yeah.
Okay.
Down is always negative, the conventions. So this is minus, the displacement is minus 0.6. Minus 0.6 because it went 0.6 down. It started here and now it's minus 0.6. Good. So what we could do now is v squared is u squared plus 2as. Therefore, v squared is equal to 2 multiplied by minus g multiplied by minus 0.6. The minuses cancel out, so v squared is equal to 2 times g times 0.6, or v is equal to square root 2g s, which is 2g 0.6. The reason I put it in this form here is because I want you to tell me, where have you seen this equation before? I'll give you a clue. Energy transfers.
Sir, is it it's kinetic? I mean, it's GPE to kinetic.
Excellent. Any question where something falls vertically, just vertically, not at an angle, not horizontally, or obviously you can't fall horizontally, but anything that falls just vertically, you could always solve the SUVAT or solve the problem using MGH is equal to half MV squared. This is always possible. But remember, the condition is it has to fall or go up vertically. It cannot go at an angle. If it goes at an angle, then we will have to do some SUVAT. So yeah, this is what you should have realized because it's the quick way to do it. So therefore, V is equal to square root 2GH because the masses cancel out. You take the 2 to the other side. So V is equal to square root 2 times 0.6 times by 9.81. Does that make sense? So write this down as a skill set. Anytime gravitational potential energy is getting converted to kinetic, or the opposite, meaning maybe something had the initial velocity of 30 meters per second, it says work out the maximum height. In that case, make H the subject, and H is equal to V squared over 2G if I rearrange this equation. So yeah, but it has to be just vertical. Anyway, so kinetic energy is conserved as the ball bounces off the ramp. The ball bounces at an angle of 70 degrees to the vertical. Well, if kinetic energy is conserved, what does it tell me about the velocity as it leaves the ramp?
It's gonna be the same velocity as it hits the ramp. So
Excellent.
it should be the final velocity will be the initial also.
Beautiful. Very well done. Let me just do square root because you can't use the rounded values. 2 times 0.6 times 9.81.
So it gives you like 3.4,
yeah,
which is around 3.
3.43 meters per second. You always have to do that in the short question. Give at least 3 significant figures for whatever your answer is. Good. So beautiful. Conservation of energy, in this case, kinetic energy, because that's the energy it had just before it bounced, half mv squared. It depends on the mass and it depends on the velocity. We know the mass of the ball didn't change and the kinetic energy didn't change. Therefore, the velocity could not have changed. If the velocity randomly increased or decreased, that means you did not obey the conservation of energy. So what we're going to do is give a little zoom in here and label this. This is 3.43 meters per second. It wants the horizontal and vertical component. So let me draw a horizontal component going this way and a vertical component. Well, I need the angle. What would the angle be? What would this angle be?
20.
20, excellent. So if you were to replicate this triangle.
So you could use 70 if you wanted to, right?
Of course you can.
No, but you can?
You can, but it wouldn't be, instead of 3.43 sine 20 as your vertical, it will be 3.43 cosine 20. I'll show you that soon.
So shouldn't you use that for the vertical component anyway? I mean, 3.43 sine 70, right?
No. As we saw from this triangle, the vertical component is 3.43 sine 20. Right? Is that what you said? Never mind. Okay, so if you want to use 70 degrees, your triangle now looks like this instead, where this is your horizontal component. So your horizontal component is 3.43 sine 70 instead of 3.43 cosine 70. And if you put this in your calculator, you notice it's the same value anyway. Why? Because this is the triangle we now have. We have a right angle triangle over here, where this is 70 degrees. And this is the horizontal, and this is 4.43. So the horizontal component, all of a sudden, is 3.43 sine 70. So yes, does that answer your question? You could have used both, depending what triangle you picked. Yes, no?
He's asking you.
Yes, sir.
Good. Is that the triangle you used?
So when I did this morning, I didn't really draw a triangle. I just guessed it and I got it right. I just imagined it and I got it right.
That was a very lucky guess because usually vertical components are always sine. So yeah, you for some reason wrote 3.43 cosine 20.
So I'm a physicist. I just imagined it.
That's what you meant. Okay, yeah, good. So horizontal is 3.43 cosine 20. Vertical is 3.43 sine 20. Of course, on your calculator, on your exam, don't you dare leave that as your answer. You always need the values, rounded values. Probably 2 or 3 significant figures. I would say 3. Okay, let's carry on. It says point A is 0.86 meters vertically above the ground and 1.23 meters horizontally from the end of the ramp as shown. All right. Did you whether the ball will bounce a second time? Well, if the ball bounces a second time, let's draw this. This is a displacement of 0. If the ball
Sir?
bounces, yes.
Says okay, wait a second. Continue. Never mind.
What were you going to answer?
No, sir, it's fine. It's fine. Continue.
Yeah, so if the ball bounces a second time, then what will happen? Or if the ball doesn't bounce a second time, let's talk about it like this. If it doesn't bounce a second time, here's an example of a trajectory where it doesn't bounce a second time. At this point here, your vertical displacement had to be less than minus 0.86. Because by the time it reached this position, you wanted it vertically to be anywhere above here, and then it would not have bounced the second time. Does that make sense?
Yeah.
So can you repeat that one more time?
So I'm saying if the ball didn't bounce a second time, by the time it reaches horizontally, we're talking horizontally, by the time it finishes traveling 1.23 meters horizontally, it's now here. You wanted it vertically to have a displacement greater than minus 0.86. So for example, if the displacement is minus 0.5, then it would have took this trajectory. So minus 0.5 is probably around here. It would have went like this. So at that moment, it had minus 0.5. Anything higher than minus 0.86 means it would not have bounced a second time. So your goal is to work out, what was the vertical displacement. Now, the whole point that I was trying to say is you could somehow not understand what to do in the question, but still get almost all the marks. And what we said is let's do the S is equal to UT approach. So start horizontally, because this is a 2-step SUVAT, obviously. You can't just start vertically. There's not enough variables. So we're going to start, and also you could tell if it's more than 3 marks, it's definitely a two-step SUVAT. They never ever give 4 marks for just one SUVAT. Never. This is a rule you should memorize. So if it's 4 marks or more, then you had to do a two-step SUVAT. So S is equal to U times T. Let's work out what the time is. The time for when it reached 1.23 meters horizontally. So T is equal to S over U, which is S is 1.23. U is I forgot. 3.43 cosine 20. Cosine 20. Someone quickly, what do we get?
So I got 0.38 seconds.
0.38. Give me one more.
381.
Yeah,
382.
Okay, 382. There's always a risk of you losing a mark if you use a rounded answer of 2 significant figures. So just make sure you don't use rounded answers until the end. So 0.382 meters. Good. So this is what I was basically saying. We could always start horizontally, then go into this vertical SUVAT.
So isn't that the time?
Oh yeah, sorry, seconds. What am I talking about? You've corrected me. So yeah, now we just do the vertical SUVAT. We know acceleration is minus 9.81. We know the time is 0.382. We know the initial velocity is 3.43 sine 20. Fantastic. I could work out any of the variables. Now you could be asking yourself, I could work out the final velocity, but in this sort of context, how useless is that? Would that tell you if it bounced a second time? No, it wouldn't. So without even having the understanding I explained to you at the start, without even like understanding what's going on, you could always start with the horizontal, plug in that same time for the vertical, decide what you have to work out. I don't think I've ever seen a question where you have to work out the final velocity in this sort of sense. So I know that I'm going to have to work out S. So it's going to be this equation, S is equal to ut plus half at squared. Let's plug in the values. So S is equal to 3.43 sine 20 multiplied by 0.382 minus 9.81 over 2. Remember, we use A as minus 9.81 because it's down. T squared, which is 0.382 squared. Someone slap this neatly into a calculator. And let's see, what do we get?
So I got negative 0.2691.
All right. Had you done this,
Sir, I got a completely different answer.
oh no,
I got negative 0.715.
we need VAR. Who's the third person with a calculator?
So let me do it again then. One sec.
Did you do 0.382 squared?
So I got negative 0.715.
That's VAR for you, I'm right.
But why? We would need to understand why was that?
I don't know.
So
I
I
think he
redid it
forgot
and
the
I got the
square.
same answer. So I redid it and I squared it and I got the same answer.
Faizan minus 9.81 over 2. And
Yeah.
then in brackets 0.382 closed
Yeah.
brackets squared.
Let me, I'll do it again. Yeah, same thing. Let me do it again one last time.
What? Do you have your calculator like radians mode? I don't know. And that has
No, I'm
anything
in
to do with it.
degrees.
Sure, you do it. You have to be like the judge.
I'm good. We'll check the mask. Because I don't have a calculator, I have my phone. Which paper was this? January 2022 Mark scheme. Which question? Question 15. 0. Minus 0.28. No one got that, right? Did anyone get minus 0.28?
Yes, that's what I said. 0.2676.
267.
What? Hold on.
Minus 0.2676.
But that's not 0.28. But that's fine. That's close enough. It just means they've rounded and you didn't round. Yeah, because they used 3.4. You used 3.43. So let's say you use 3.4 instead. What do you get?
So I'm so confused how it's 0.28.
I will do some VAR stuff, okay? On your calculators, 3.4, first of all, please degrees, okay? Everyone degrees, not radians. 3.43 sine 20 multiplied by 0.382. What do we get?
So what's the answer? Minus 0.767 or minus 0.26? Whatever.
It says in the mark
Sir,
scheme.
I got
Minus
0.4481.
No, you're getting a different answer.
No, this is for like another question he's asking.
Oh,
Yeah, so
So
what's it?
3.43 sine 20 times 0.382 gave me 0.4481.
4481. Confirm, please, Fazan. And then on your calculators, minus 9.81 over 2 multiplied by 0.382 squared. By the way, Fazan's right according to Mark's scheme, but I just want to know what the two other people did. How can two people get the wrong answer? Doesn't make sense.
now I'm getting minus 3055. So I keep getting a different answer. What? Now I'm getting
I'm still
minus
getting
3055.
so I'm still getting minus 0.716.
Are you in radians or degrees?
No, I'm
So I'm
in
gonna try
the
to.
normal.
Okay, just reset the calculator.
Wait. Okay, like, I'm trying to make it simple. What did we get for the first section? 3.4.
Yeah, I got that.
Okay. Second section, what did we get? So minus 9.81 over 2 times by 0.382 squared.
382 squared
So I got the
minus
same thing as Faizan.
0.715757722. So then you subtract it. Wait.
So I got negative 0.267.
Yeah, that's what I got too.
So I'm still getting 0.716.
Salih, I know why you're getting
Or
that.
are you putting sine 70 or sine 20?
Did you? No, it's because you didn't subtract the 0.4481 by the negative 9.81 over 2.
Oh, you're
Did you
supposed to do the
subtract the first
entire.
bit?
You're supposed to. Oh, wait. There's
Yeah.
so wait. I'm supposed to do 3.43 sine 20 times 0.382 minus 9.81 over 2, and then 0.382 squared.
Yeah, multiply. These are multiplied.
Oh, okay. Now I'm getting minus 0.267. So I thought it was only the second line equation, the minus 9.81 over 2 times 0.382 squared.
Oh, you ignored this part.
Yeah, sure,
No.
because it was
Silly
like on
Billy.
another line.
You
Goofy.
guys had me confused. I thought, what? We're gonna have to do a calculator lesson. Okay, anyway, so good. So this is correct. Fantastic. So looking at that, meaning once you traveled a horizontal distance of 1.23, you would have traveled a vertical displacement of minus 0.28, meaning somewhere around here. Does that make sense? So you would have took a path like this. Would it have bounced the second time?
Sir.
Yes.
Oh,
So what does it mean minus 0.28? So it's
Because
0.28 meters under 0.6.
because here is where you started, i.e., where you started, displacement is 0.
Ah,
So it would have
I see.
been minus 0.28. But do you guys understand how, like, my hypothesis apparently is true so far? Start with the horizontal, work out the time, plug it in the vertical, work out whatever you think is most appropriate. Hopefully no one would have worked out the final velocity, because I don't know how that's going to help in this context. Work out both if you need to, but usually it's just the displacement. Not the final velocity is very, very rare.
So Miss, our teacher, he's called Mr. Phillips. He couldn't solve this question today. He didn't know how to.
Tell him to join my lessons. Yeah, so
Mr. Dabusi solos.
no, because I think basically I can try to teach you how to understand the question. And in this question, by the way, there is 4 ways to solve it. 4 ways. One way doesn't even involve SUVAT. I can try get you to understand like how to answer this question, but just because I explain how you understand this question, it doesn't mean you're going to understand the future question. That's why I always focus on skill sets. I feel like especially this year due to COVID, the general understanding of physics is really, really weak. Meaning, my strategy is now, what skill sets can we take from questions that appear to be the same for every question, and we focus on that, and that's basically the strategy. So let's try find one more SUVAT question and see if it applies. But I'm pretty sure it applies. But let's just, I don't know, January 2021. Let's have a look.
The thing is, SUVAT questions for me were extremely difficult, but now because of you, sir, it's like a lot more understandable.
Oh, is this a SUVAT?
Yeah, it is. I remember that.
All right, shall we test hypothesis? All right, let's test the hypothesis. Okay, show that the initial speed of the ball is around 17 meters per second. Everyone have a go.
So what paper is this? So I can open it.
January 2021.
So to be honest, I have no paper next to me. Wait. I think I found a notebook.
Silly Billy. Okay, physics lesson without paper.
Okay, sir, false alarm. I have my notebook.
Okay, I'm glad. Oh, Mohammed told me, how do we start such a question?
We write down the horizontal SUVAT.
You can, but we haven't been given a horizontal distance or even time. So if you write,
I mean the vertical, sorry, I meant the vertical.
yeah, good. Because if you do a horizontal SUVAT to work out U, fantastic, good chance. Okay, U is equals S over T. What's S? I don't know. What's T? I don't know. So you could have started like that. But what's nice to notice is you're given vertical displacement and you know the acceleration is minus 9.81. So what we're going to do is the vertical SUVAT.
So,
Good start.
so shouldn't it be
Oh.
positive 9.81?
Yeah, I was gonna say that.
No, absolutely not. Is
But
it?
so you said when it
is
goes
it
up.
No, acceleration's always minus 9.81. Always.
Huh?
What's your teacher teaching you? I'm so confused. Because
sir,
when
because-
you hit something above the ground, what's the only force acting on it?
Gravity
Gravity. Where's this resultant force acting?
downwards.
Downwards. So your resultant force is always downwards, i.e. your acceleration is always downwards.
But so I thought you said if it's upwards, it's 9.81. If it's downwards, it's minus
Yeah.
9.81.
No, I'm saying your teacher said it's positive 9.81, right? Meaning your teacher took up to be negative and down to be positive. That's what I was saying. What I'm
Yeah,
saying when
yeah.
I'm teaching is always minus 9.81.
And it works. You can just always put it as minus 9.81,
Always,
even if it's
always,
going up,
always.
down, wherever.
Up, down, left, right, because the force is always acting down. So the
So would it be
acceleration
the same in M1 in math?
is the exact same in M1.
Okay, sir. Thank you.
Just remember, up is positive, down is negative. Where is the ball accelerating upwards? If it was, it will go to space. We'll never see it again. No, it's accelerating downwards. It's i.e. decelerating. It's getting slower and slower and slower because gravity is pushing it down. So yeah, we know acceleration is minus 9.81, as is always the case. There's never been a scenario where it's positive 9.81. And then what we're going to do is, what is the displacement?
5.
Positive 5. Why is it not negative 5? Because it didn't end
Because,
here, right?
yeah.
It ended 5 meters
And
above.
then,
Up is positive.
and
Good.
then sir, would the final velocity be 0 since it's reached at a maximum height?
Well, I didn't even read that. So yeah, if it reaches a maximum height, final velocity is indeed 0. So anyway, S is 5 meters. Good. It wants to show that the initial speed is 17 meters per second. So what we can do is work out our initial vertical velocity using v squared is equal to u squared plus 2as, because that's the equation prescribed. Let's work out v is 0, i.e. u is equal to square root 2gs, which is square root 2 times by 9.81 times by 5. He wants to calculate this for me.
So I got the final answer 17.268, which is basically 17.
Okay, but what did you get for the initial velocity? Initial vertical velocity.
So that's not what I used. I did v squared equals u squared plus 2a. Oh, yeah, that's what I used. So I did 0 squared equals u sine u sine 35 squared plus 2 minus times minus 9.81 times 5. I rearranged it. So u sine 35 equals root of 98.1. So I
Hmm.
divided by sine 35 on both sides and I got 17.26.
You were being cheeky. I didn't even bother. Like, I thought like this would be too difficult to explain. You used u sine straight away for the vertical. What I'm doing is I'm just working out the vertical, because not everyone can realize you have to use u sine 35 straight away. So what's square root 2 times 9.81 times by 5?
So I'm just a physicist. Like, what can I say?
Fair enough. Fair.
So I got 9.90.
9.90. That's the initial vertical. So I know what the initial vertical is. I'm trying to work out this, the overall x. I know what the vertical is, which is 9.9. I know what the angle is. Trigonometry should give you x's whatever Faizan got by doing his cheeky little method. So what do we have? We got the opposite. We got the hypotenuse, so sine 35 is equal to 9.9 over x. X is equal to 9.9 over sine 35. What do we get?
$17.2.
Good, 17.2. Yeah, Fazan, if you could realize that stuff, go for it. No, absolutely no problem. For the rest of us, this is how you tackle it. Any sort of question like this. Okay, anyway, so now this is the 5 marker. This is the 2-step SUVAT. We already know it's 2 steps, 5 marker. So let's let's just ignore the question and start by doing S is equal to UT. Bismillah, let's see if this works. So therefore, T is equal to S over U. I don't even know what I'm solving right now. Where S is, okay, I think now I need to read the question. So I know what to put for S and what to put for U. So it says, after traveling a horizontal distance of 22 meters, the ball reaches the goal. Where's the goal? Oh, this is nothing to do with it. The ball reaches, is this rugby or football? Oh, rugby, okay. The ball reaches a goal. I know what kind of football goal is that. To score, the ball must be more than 3 meters above the ground when it reaches the goal. Deduce whether an initial speed of 17 meters per second is sufficient to score. Okay, now I kind of know what to plug in because it says after traveling a horizontal distance of 22 meters, i.e. 22 meters horizontally, divided by the initial velocity, which is going to be u cosine the angle. What's the angle? 35. So u 17 cosine 35. What do we get as a time?
One 1.5798.
Right, this round to 3, 1.58 seconds.
Just to be sure.
Yeah. So SUVAT. We're going to jump to the vertical. We're going to slap on the horizontal time, which is 1.58. We're going to slap on minus 9.81, which is always the acceleration. Initial velocity, we know it's 17 sine 35. We need to know the vertical displacement. Remember, like last question, I said it's usually this. It's not the final velocity you're working out because that's pretty useless in this question. I want to know, is it 3 meters above the ground? So I want to know what is the vertical displacement. Put a question mark here. Once again, we're left with S equals UT plus half AT squared, which is going to equal to 17 sine 35 times about 1.58 minus 9.81 over 2 T, which is 1.58 squared. Calculators, but hopefully we have unanimous decision.
So I got 3.16 meters. So it's
Super.
just above it.
Do you want it below, above or below? How do you play rugby? It must be
You need
above.
it above it.
Okay, so therefore,
I got 3.16 as well.
okay, good. I like that. Our calculators agree. Did it work? Absolutely, it worked. I do.
Sir,
Listen.
what if someone?
Hmm?
So
Yeah.
what if someone just doesn't know how to play rugby? Like, sir, in this question, I don't know if I'm supposed
No,
to go upwards or
I know,
downwards.
because it says, I quickly read the question as soon as I thought the same thing. It said to score, the
Oh.
ball must be 3 meters. Yeah, otherwise it's dumb.
Oh, okay.
It's very dumb. You're right. So yeah, according to what I've seen from your past papers, I've only done, I'll be honest, for your syllabus, because I used to teach a different syllabus. I've only done June 2019, January 2020. I've done the mocks with my class, so 2022 and October 2019. So those are all the papers I've done. But from every single one I've done, I've noticed this is always the case. And I know from my old syllabus that there was a similar pattern. There was a very similar pattern. So I'm just going to say for now, until proven otherwise, well, I don't think we will be proven otherwise. If you don't know what to do, just start with the horizontal, slap that on into the vertical, and then try to understand what's going on in the question. I think that will be easier, right? So that's what we should do from now. Just remember acceleration is
sir.
minus 9.81 and to plug in the right values. So horizontal is 22 from this context.
Sir,
Yes.
it's just acceleration. It doesn't matter if the ball is going up, down, left, right. Like it's always minus 9.81.
It's always 9.81 when the only force acting on it is gravity.
So how am I supposed to know that it's like then when is it going to be positive 9.81?
It's never ever positive 9.81.
So why do our teachers tell us to use positive 9.81? So that's so
your teacher for some reason decided that negative down is positive.
yeah, he did tell us that. Both of them, even math. For M1, he told us if it's down, it's positive, if it's up, it's negative.
Yeah, this is not a very physicsy convention. Perhaps in maths, they try to avoid the minus because they're scared of minus. Maths teachers, I know them. I know for a fact maths teachers, they're scared of the negative values. But
Mr. Khan
physicists,
tell you that.
no. But I just know from my experience with maths teachers, they avoid the negative. I see them, they'll have like a quadratic equation, minus t squared plus 3t minus 17. For some reason, I don't know why they'll convert this to t squared minus 3t plus 17. You accomplished nothing doing that.
Sir, I always do that, to be fair.
Yeah, but I'm just saying a true physicist realizes there's nothing to accomplish doing that. You could solve this the same way you solved that. So I think maybe that's why they're doing positive 9.81, just because they're terrified of negatives. So they decided to forcefully make down positive, when naturally, even in maths, because in maths, when you're drawing graphs, where's the positive quadrant? This is positive. This is positive. Up is positive, right is positive. Yes.
So for this type of question, always you just you do S equals UT from the horizontal, you find the time and you just plug into the distance of the vertical. And the acceleration is always minus 9.81.
Always 9.8 minus 9.81 for projectile motion.
So can we do one more?
But I just want you to know if something's in an inclined plane, right? There's mg down, right? However, as we discussed in the previous lesson, the horizontal component of mg is mg sine theta. Your acceleration is no longer minus 9.81. Your acceleration is now minus mg sine theta. Because you need the force and the direction is moving. Does that make sense? So this is the only sort of scenario where you won't have to use minus 9.81. Rather, it's minus 9.81. Sorry.
So, sir,
minus 9.8. Forget about the mass. Minus 9.81 sine theta. Yes.
So, sir, the only time acceleration isn't minus 9.81 is if it's going down at an angle, which is then you have to like consider sine theta.
Yeah, if the only time the acceleration is not minus 9.81, let me rephrase what you said, is when the resultant force acting on it is not weight. And in this case, it wasn't weight. It was weight sine theta.
Friction force?
No, it's at an angle now. Because you considered the resultant force here, not down anymore.
Okay. Yeah, because it can't go down.
But yeah, otherwise, if the only force acting on it is weight down, which is everything else, the ball, as the ball is going up, the only force acting on it is weight, wherever it is, then yes, your acceleration is minus 9.81. Can we do one more question? All right, let's go to the next past paper.
Yeah. So you know this question that we just did that you solved in like 2 minutes. It took our teacher like a half an hour.
Yeah.
Oh, to be fair, I would have solved it in like 5-10 minutes.
No, because like we didn't really know the steps, but now we know how exactly to do it.
What's this? Cheeky trolley. Is
So,
this
sir,
a SUVAT?
what you taught
Wait, is
us?
this a SUVAT angle? Even better. Shows that blah, blah, blah. No, that's energy transfers. Oh, it is. Are you guys ready
Sir,
for
is this
this?
where you would use? Is this where you would use V equals square root 2gh?
This is when you no longer could use accelerations minus 9.81. Shall we skip this and do this later and try find one more that you do use it? Just so we
Sir,
don't.
I have one really important question also.
Yeah.
Our physics mock is on next week, Thursday, okay? So there's gonna be, we already have one physics lesson that we postponed. So are you free on Wednesday by any chance? Or
I'm
on
only.
on Wednesday?
When's your mock? Sorry.
Thursday.
This Thursday. The next Thursday.
Yeah, like 1 week time.
How's my schedule? So Sunday I'm not free because I've rescheduled 2 lessons on Sunday already. So Sunday I have my 2 lessons. Monday I have my 2 lessons. So the only thing I could reschedule is the Monday because this one's a group. I can't reschedule groups, it's too difficult. But this person has to accept. So we'll speak to the Monday person.
Sir, I don't think Monday works because I have 2 exams on Tuesday that aren't physics, being computer science and mechanics. So like I kind of have to focus for those ones.
Wednesday I
So,
have
sir,
a non-group
if you
at
can't, it's
7
fine.
o'clock. You wanted Wednesday, right?
Yes, sir, Wednesday, or if we can extend like the Tuesday lesson maybe or something. Actually, no, extending the Tuesday lesson won't work because like our brains will fry.
So if the Wednesday person can swap with your Thursday lesson, because you would have done the mock anyway, then that is possible. I'll ask him if
Okay,
he
thank
can.
you, sir.
We'll see. Anyway, let's. I was saying this.
Sir?
You know what? Let's do that question. Whatever that question was. Angle. Let's go for it. So, party. Yeah, ask a question, Fazan. What's the question?
So I was saying, can you give us the mark scheme for the October 22?
No, it's illegal.
So why is it illegal? What?
I don't care if it's illegal, but I know it's haram. Like I'm a Muslim, practicing Muslim.
Oh, okay. Okay, that's
Yes.
fine.
Why is it illegal? Because when the teachers go on the website to get the mark schemes, there's a terms and conditions. You cannot distribute this paper to anyone outside your organization. Meaning, if you knew students from my school who did the paper, I guess they could give it to you. But I don't think you know anyone from TEA, do you?
No, so actually, I met the under 19 team when they were playing the volleyball game.
Yeah, but
I
don't
talked
think
to a few of them.
none of them do physics. My physicists in my school are not sporty.
So Amr, what's his name? Amr. Yeah.
No, he doesn't do physics.
Oh man.
But you know what? It's fine. You want to have like a genuine attempt at the mock to see your level, your improvements, your blah blah blah. It's really helpful. You don't understand how helpful mocks are. You learn so much from them. So it's better to have that authentic attempt anyway. And even if you have the paper, I would say don't even look at the paper. Just go for it. Your exam is literally 5 weeks or 4 weeks after your mocks anyway. 5 weeks. So like, it doesn't matter if you do well or bad. It literally doesn't. Just learn from it. I got so many students who got like C's and D's for the mocks, but I know they're going to get A's, inshallah, for the real exam.
So do you use the same method? You find the time and then you find the distance?
No, because first of all, it's a free marker, meaning we don't know if it's a two-step. We don't 100% know is it a two-step SUVAT. Does that make sense? It's not 100%. So
Yeah.
I'm not going to start with that cheeky little method. What we're going to start instead is think about other stuff you might know. It is the same sort of thing we literally did last session, or even at the start of this session. I'll give you a clue. Energy transfers.
So do you do MGH equals half MV squared?
Good, because all its kinetic and all its gravitational potential energy has all been converted into kinetic energy in one direction. So of course you could use energy transfers.
Yeah, and sir, for the vertical component, I don't think you can use 0.50, right? Because it's like, or can you?
I think you can.
Where did you get 0.50 from?
0.50
the-
meters.
The height.
For your, you can use that for your vertical.
So you just do V equals square root 2 and then 9.81 and then 0.5 for the H.
What, are you surprised?
No, so I was just like making sure.
What did you get?
And would that be all 3 marks?
Listen, the
Wait,
marks.
let me check.
It will be 3 marks. It will. I've seen this 3 marker before.
Yes, sir. 3.13 and then which
Yeah, I
is
got it
around
too.
3.
Yeah, around 3.
Yes, sir.
The reason
I'm
it's
so
3
thankful you're my
marks.
physics teacher.
No problem. So the reason is 3 marks. Let me explain why it's 3 marks. They have to give marks to people for the B's and C grade students. How are you going to get a C grade if you if they give you 2 marks here or 1 mark here? Does that make sense? So usually how it works is part A, easy peasy, part B for B A star / students. So when we look at part B, we now see 4 marks. What are you thinking?
Two-step SUVAT.
Perhaps a 2-step SUVAT. However, there's one problem now, which I told you. It's an inclined plane. It's no longer that simple.
Sir, but we can solve for the angle, right?
We can solve for the angle, good. So
Is that what we do?
what we want to do is work out what the acceleration is. So I'm going to give you a clue because I do want you guys to have a little attempt by yourself. I'm going to give you a clue. Remember, you're trying to find this component where this is theta. Exact same thing we did in the first past paper with the, what's it called? The tension and the useful energies and total energy, that question.
So
So
the angle that
here's
you're
your
trying to
clue.
find is the one next to the trolley.
Yeah, because the trolley is moving this way. This is
Yeah,
where it's
that's what I
accelerating.
was thinking.
Yeah, this is where the trolley is accelerating. Meaning, am I going to do a vertical SUVAT or a horizontal SUVAT? The answer is no, because it's not moving vertically or horizontally. Rather, it's moving this way here. So can you somehow do a SUVAT where everything is now in this direction, i.e. the displacement will be in this direction? How could you work out this displacement? Look at that Pythagoras theorem. You're given 2 meters and 0.5 meters. So I could work out the displacement in this direction. Is the initial velocity 0? I'm guessing a trolley accelerates from rest. I know the initial velocity is 0 in that direction. But I need more. I need one more.
Sir, would V would be 3 and then cosine and theta, right? Or 3 sine theta, I mean.
V.
Yeah.
How do you get that?
I mean, not V, sir. Sorry, I meant A.
Excellent. So because there's nothing given on time here, absolutely nothing given in time. But I do know that there's mg or there's g here, so therefore there'll be g sine theta. So yeah, good, excellent. I want you to do the rest at home, just because I'm gonna miss the football game soon. And that's basically it. But does it make sense that for this sort of question, I couldn't just do S equals UT anymore? I couldn't use that approach because A is not minus 9.81, meaning I can't do a traditional orthodox vertical SUVAT. I just couldn't.
Which, why not?
Because for me to say that, for me to do a vertical SUVAT, how do I explain this? You know, technically you can. Technically, you could resolve it horizontally or vertically, but it would have been so much longer. I'm just saying for this sort of question, I know that the truck is moving here, right? This is not horizontal, this is not vertical. So let me resolve my SUVAT in this direction, in the direction it's moving.
Sir, I have a question.
Yes.
Can you just tell us how to solve for the angle? Because my brain is kind of fried, so the math isn't mathing.
Sokotoa.
Has see this triangle here? Oh, how to get the angle, you mean?
Yeah, the angle that we need for the acceleration.
You have 2 and 0.5 opposite hypotenuse. So you have the opposite and the adjacent. So tan theta is equal to opposite, which is 0.5 over adjacent 0.2. Theta is tan inverse this.
Oh, okay, yeah. Okay, thank you, sir. I just completely had like a brain fart here.
Yeah, no problem. So yeah, that's how you would solve this. By the way, to answer someone's question, you could have done it horizontal. You could have resolved it in the horizontal and vertical components, but all of a sudden it's so hard because your horizontal and vertical components are no longer the usual minus 9.8 and 0 anymore. But it's possible, and there's another possible way as well that we'll talk about next lesson. So instead of you could have pretended it's a projectile motion just by rotating this at a certain way. But anyway, we're not going to talk about those methods. We're just going to talk about the first method. This is the method that I want you to use because this is the method that will always be the method to do for an inclined plane. This is a separate skill set. So when you're talking about inclined planes, you're doing this. So this is really easy. So you to know when to do. Just if you see an inclined plane question, you are resolving the component at this way. And we've done this before. Remember the June 2019 paper? We've done the exact same skill set here in this inclined plane. We had to resolve the force at that direction or acceleration at that direction, whatever you have to do. So this is just the inclined plane skill set. So any inclined plane question, I want you to be not thinking about, let me do S is equal to UT first, and then use that T over here. Very possible. It is possible. You could try it if you want. It's difficult. It's very difficult, but it's very possible. I'm just saying your exam doesn't expect you to solve something that difficult. Rather, it will give you a context, and there's always an easier way to solve it. And this inclined plane, you're going to do what I did over here. So work out all the components in the direction it's moving, and then do the SUVAT in that direction. So yeah, have a go, think about it, and I'll see you guys next lesson on Tuesday.
Bye, sir.
No problem. Bye.
So basically,
Alright, so thank you.
so
Yes.
for this question, you just resolve what exactly would you resolve here?
So I'll explain it one last time. Remove all this nonsense. I know the truck is moving in this direction, correct? So I'm going to do a SUVAT where everything in the SUVAT is in this direction, the direction the trolley is moving. Well, do I know the displacement in this direction? Yes, I do. Pythagoras theorem, a squared plus b squared equals 2 squared. So square root 0.5 squared plus 2 squared. Does that make sense? So
Yeah,
far?
got you.
What's the initial velocity? It started at rest, so 0. I don't know the time. I don't know the final velocity, but I do need to know the acceleration. Right? So
So isn't that positive 9.81?
no, because it's not down.
Faisal.
I'm sorry, but I thought you said if it's going up or down straight, it's negative 9.81, but on a plane, it can be positive 9.81.
It's not.
Then he was saying how since it's going at like a certain angle, since it's not going fully vertical or horizontal, you have to do 9.81 sine like theta, and
So,
then that would
Fazan,
be your actual acceleration.
so there
Yes,
is
sir.
minus 9.81 vertically downwards. There is, you're right. Okay. But am I doing a vertical SUVAT? No, I'm doing a SUVAT in this direction. Okay. So I
So,
want,
so every question that's like on a plane, like on
Yeah.
like whatever this is, you have to resolve it. You have to resolve the gravity,
yeah.
the acceleration figure. Oh, okay.
Yeah. So instead of getting this red one, I want this green one, this green component, where this is theta. So it will be minus 9.81 sine theta because it's opposite the angle. Here's a hypotenuse. It's the same, like, it just means, you know, this question here that we've done before, which is recorded, study it in more detail, and it'll make this one even simpler. But yeah, because it's moving in this direction, I wanted the acceleration in this direction. I don't want the minus 9.81, which is always down. I can't do that. That's not the direction I'm resolving in. So that's why I have to do the angle.
Okay, so one last question. It's quick,
Yeah.
okay? Sorry for holding you up, but
No problem.
so if it's going straight up or down, it's negative 9.81. Since it's on the straight track, you have to resolve your mg. You get it in the direction of the movement of the trolley, and then just put it into your SUVAT, and then you find your time taken.
By the way, one last thing you could have used, you could have used the final velocity to be 3.13. I'll let you think about that in your own, how this is also possible. But yeah, I just thought I would explain this way instead, because, you know, I have to get a bonus of resolving. Anyway, so I will see you all on Tuesday. We'll talk about this again. You go home, think about it, get your questions ready, and we'll redo this question again, and maybe some other inclined plane questions. All right, take care, everyone.
Okay, so thank you so much. This lesson
Bye,
really,
Bye,
sir.
sir.
really
Thank you
Thank
so
you.
much. This lesson was really useful, sir. Thank you.
No problem, anytime.
Thank you.
Bye, bye, sir.
Bye.